Okay, grade 12s, good morning. And welcome back. Grade 12, so we are busy with acids and bases. And you'll see in the notes that you received today, there is a table that looks like this. Remember last week someone asked about the polyatomic ions. Does this look familiar? It comes from the grade 10 exam guidelines. So when I refer to a polyatomic ion, I am referring to ions that consist out of more than one element. So that would be something like ammonium, NH4, because it consists out of nitrogen as well as hydrogen. So that is called a polyatomic ion. You need to know your polyatomic ions, the formula, as well as its charge. So you need to know ammonium is NH4+, okay? And hydronium is H3O+. And then when you get to the negative polyatomic ions, we have hydroxide, which is OH, negative, hydroxide. You have nitrate, nitrite, etc. So there we have all our polyatomic ions. So ions that consist out of more than one type of element. Grade 12s, this is very important because not only is it important to balance formula, sorry, it's also going to be important when it comes to electrochemistry. Okay, so you need to know your ions. Apologies, grade 12s. I'm not sick. I don't feel sick, but I sound very sick. But really, I'm not, okay? I am very okay. So please do not be alarmed or worried. Okay. So last week, we finished off with question 1. And I'm going to leave question 2 for you to do on your own. Because question 2 is a lot of theory, okay? So it's developed or designed in such a way to help you to study the theory. So things like your definitions, etc. So a very nice question. It's very grade 11 level. So you should be okay with question 2. The question I do want to start with is question 3. So last week, I suggested, it was a suggestion, that you go home and spend some time with the theory for acids and bases. You remember that? It was a very strong suggestion. Because if you do not know the theory, then the application becomes very difficult, okay? And this is a very good example to demonstrate how the theory is important for application. So we're going to look at question 3, which is from the notes from last week. You remember? No. Whoopsie. I think there's a few extra notes from last week left. So if you didn't get notes last week, there's still a few notes left. Okay, but only if you didn't get last week, eh? If you got notes last week, but you left it at home, you're on your own. Okay. You can get your notes quietly, please. Thank you. Come in here unprepared, grade 12s. Okay, I'm going to start. During a practical investigation, grade 12 learners decide to determine the percentage of ethanoic acid. So they want to determine the percentage of ethanoic acid in a certain bottle of vinegar. Now you know vinegar is a mixture between water and ethanoic acid. So they titrate a sample taken from the bottle of vinegar with a standard solution of sodium hydroxide. The equation for the reaction is as follows. Okay, now let's just quickly sit with the information given to us. we have a bottle of vinegar that, of course, contains ethanoic acid. But vinegar is not 100% ethanoic acid. It is a mixture between ethanoic acid and water. So they want to determine what is the percentage of ethanoic acid that's actually present in the vinegar. And then they also tell us that they're going to do a titration using a standard solution of sodium hydroxide. Now, immediately, two very important things. Sodium hydroxide, you need to know immediately, is a strong base. Immediately you know it is a strong base. It is a standard solution. So what is a standard solution? It is a solution of which the exact concentration is known and the concentration remains constant over a period of time. So usually in a laboratory, what we would do is if we have a solution of unknown concentration, as in this case, they have a solution of ethanoic acid, but they do not know the exact concentration of that ethanoic acid. So what we then do is we set up a titration, and we use a standard solution that has been prepared according to a very specific concentration. And then we titrate it against each other to determine the concentration of the unknown solution, or the unknown concentration. Okay, so that is why we use titration reactions. Now, ethanoic acid, what is special about ethanoic acid? You need to know it is a weak acid. So immediately you know this is a titration between a weak acid and a strong base. So if we go to our notes, these notes, we have a weak acid and a strong base. So immediately you know hydrolysis will occur. Because it is a weak acid and a strong base, the solution will become basic, which means the pH will be larger or greater than 7. So yes, hydrolysis will occur. The pH will be greater than 7. Why? Because you will now have more hydroxide ions in the solution. And the indicator that we're going to use in this titration will be phenolphthalein. Okay, so before we have looked at the questions, we are just busy to analyze what we have in front of us. But this is information you already have. You already know. The moment you see weak acid and strong base, you need to trigger that information. You need to think immediately. Hydrolysis will occur. Hydroxide ions will be more. pH will be greater than 7. Phenolphthalein. That is what you're thinking. The moment you see it's a weak acid and a strong base. So again, do you see why it's important for you to study which acids and bases are weak and which ones are strong? Yes, because if you don't do that, the application is going to be a nightmare. But if you do know your theory, do you see how easy it is? It's very easy. Okay. So we have ethanoic acid that reacts with the sodium hydroxide to form a salt and water. What is the ratio in which they reacted? It is a 1 to 1 to 1 to 1 ratio. So very simple. Then the first question, define the term standard solution. So you need to know what a standard solution is. A standard solution, like I said, is a solution of which the exact concentration is known. And that concentration will remain constant over a period of time. Classify ethanoic acid as either a strong acid or a weak acid. It is a weak acid, and then give a reason for your answer. So when we have to give a reason for why we are saying something is a weak acid or a strong acid, all we do is we write down the definition. So it is a weak acid. Why? because it will ionize incompletely in water to form a low concentration of hydronium ions. Okay. Classify sodium hydroxide as either a strong base or a weak base. It is a strong base. Why? Because it will dissociate completely to form a high concentration of hydroxide ions in solution. Happy with that, grade 12s? Okay. Then, define an acid according to the Arrhenius theory. So, was Arrhenius which guy? The guy that said an acid is a proton donor, or is it the guy that said an acid will form hydronium ions in solution? Yes, because Lowry-Bronsted is the theory that said that an acid is a proton donor. So yes, according to Arrhenius, an acid forms hydronium ions when it dissolves in water. Okay. And then define an acid according to the Lowry-Bronsted theory. According to Lowry-Bronsted, an acid is a proton donor. Identify an appropriate indicator for this titration. Weak acid, strong base, so we've already identified it as phenolphthalein. Okay. Give a reason for your answer in question 3.6. So, the first part of your reason is the fact that this is a titration between a weak acid and a strong base. That's the first mark. This is a titration between a weak acid and a strong base. And then the end point of neutralization will be smaller than 7, and the pH range of phenolphthalein is 8.3 to 10. A pH of 8.3 to 10. So that is your second mark. Okay. So because the pH is going to be greater than 7, we need to use an indicator that has a pH range that is greater than 7. And in this case, it's going to be phenolphthalein. Okay. The learners find that 40 milliliters of a 0.5 moles per decimeters cubed sodium hydroxide solution is needed to neutralize 20 milliliters of vinegar. Okay, now let's look at that sentence. 40 milliliters of a 0.5 moles per decimeters cubed sodium hydroxide solution. So let's break it up. What quantity is 40 milliliters? It is the volume that's given to you. However, we usually work in centimeters cubed, which we convert to decimeters cubed. But now they give it to you as milliliters. And in grade 10, you learned what? You learned that 1 milliliters is the same as 1 centimeters cubed. So in other words, this is the same as 40 centimeters cubed. So this is the volume. So the volume needs to be converted to decimeters. How am I going to convert centimeters cubed to decimeters cubed? Divide by 1,000 or times 10 to the power of negative 3. So that's the volume of the sodium hydroxide. What is 0.5 moles per decimeters cubed? What is that? It's the concentration. So the concentration and the volume is for the sodium hydroxide, which is the base. Okay. And it is needed to neutralize 20 milliliters of the vinegar. The vinegar is the acid. And the volume is 20 times 10 to the power of negative 3 decimeters cubed, or just divide by 1,000. It is the same. So what I have is I have the concentration and the volume for the base, and I have the concentration for the acid. Define a base according to the Arrhenius theory. So according to Arrhenius, a base will form hydroxide ions when it dissolves in water. A base according to Lowry-Bronsted, a base is a proton acceptor. Yes, well done, grade 12s, you know your theory. Calculate the pH of the sodium hydroxide solution. The pH of the sodium hydroxide solution. Now, when you have to calculate the concentration of an acid, if it is a monoprotic acid, like we saw last week, it will ionize in a ratio of 1:1. So one acid will form one hydrogen, which means it will form one hydronium. So if the concentration of the acid is 0,3, the concentration of the hydronium ions is also 0,3, and we substitute that into our formula. But as per formula, we need the concentration of the hydronium ions. So now we are working with a base. We are now working with a base. So if we look at sodium hydroxide, it is going to dissociate to form sodium ions, which I'm not interested in at the moment, and hydroxide ions. But it is going to dissociate in a ratio of 1:1. This is hydroxide ions. So they've specifically told me here the concentration of the base is 0,5. So the concentration of hydroxide is also 0,5. You agree? What is my problem here? I need the concentration of the hydronium ions, not the hydroxide ions, to calculate pH. So how am I going to calculate the concentration of hydronium ions? I don't have enough information, do I? So what am I going to do? And your other problem is because you could say to me, yeah, but you have enough information to calculate the concentration of the acid. Nay. So then you can calculate the concentration of hydronium ions. You would be wrong. Why? Grade 12, it is a weak acid. And a weak acid only ionizes partially, incompletely. So in other words, we cannot work with the acid. We can't. Okay, we can't. And anyway, we need to calculate what? We need to calculate the pH of the base of sodium hydroxide. So we're a little bit in trouble here, are we? No, we're not. I'm going to refer you to your data sheet in the notes from today. You see this little guy here? Very important. Very important. It is a constant. The concentration of hydronium ions multiplied by the concentration of hydroxide ions will be 1 times 10 to the power of negative 14. Which means, if I have the concentration of hydroxide, I can calculate the concentration of hydronium, because it's going to be 1 times 10 to the power of negative 14 divided by the concentration of the hydroxide. Okay, so when you have to calculate the pH of a base, you have an extra step. You need to first calculate the concentration of the hydronium before you can go to your pH formula. Happy with that? So I'm going to write it down here. What number are we busy with? 3.8.3. And then I'm going to ask you to do the math for us so long. So we're going to say H3O plus times OH negative gives us 1 times 10 to the power of negative 14. And therefore, the concentration of the hydronium ions will be 1 times 10 to the power of negative 14 divided by, Yes, 0,5. Ooh, that is a 5. It looks like a 6, but it is a 5. Can you see it's a 5? Oh, I'm just making it worse. Does it look like a 5 now? Okay. You do the math for us so long. Let's see what you get. What do you get? Oh, you can't get, that doesn't sound right to me. Sounds like you maybe need some fresh air. Do you get 2? Yes, times 10 to the power of? Negative 14. Yes. Now, grade 12s, I can go to pH is equal to, and I'll just write down my formula. And now I substitute. And now you do that on the calculator. And remember, this is a base, so do I expect a pH higher than 7? Yes. And it's a strong base, ne? What do you get? $13.7. Okay, so that is the pH of the sodium hydroxide. Happy with that? Okay. There's my questions. Okay. Now they ask us to calculate the percentage of ethanoic acid by mass present in the vinegar. They could have just as well have asked you to calculate the percentage purity of the ethanoic acid. Okay, it's the same thing. They just want us to determine how much ethanoic acid is actually present in the vinegar. So now, they also tell you, assume that 1 milliliters of vinegar has a mass of 1 gram. Now, because they told us right in the beginning that it is 20 milliliters, 20, or where did they tell us? There. They told us at 3.8 there, it's 20 milliliters of vinegar. So that also tells me that it's 20 grams of vinegar. So I have the mass of the vinegar. So what I need to do is I need to determine what is the mass of the ethanoic acid that reacted. And then I just divide it by 20 and multiply it by 100. Then I have the percentage. Okay. But now the problem is, I only know the volume of the vinegar, of the ethanoic acid. I only know the volume. It was 20 milliliters. And it's impure. It's not pure. But it was 20 milliliters. They say here, the learners find that 40 milliliters of a 0.5 mole sodium hydroxide solution is needed to neutralize 20 milliliters of the vinegar. Okay, so I have enough information to calculate the number of moles of sodium hydroxide, correct? And then, very important, the sodium hydroxide and the ethanoic acid is in a ratio of 1 to 1. So then I can calculate the number of moles using the ratio of the ethanoic acid. And then I can go to mass from there. And then I divide it by 20. Okay, so let's quickly do that. So this is 3.8.4. Okay, so I'm going to work with the sodium hydroxide first. Okay? C is equal to N over V. It's on my data sheet. The concentration is 0.5. Moles is what I want to calculate, and the volume is 40 times 10 to the power of negative 3. Therefore, the number of moles of sodium hydroxide is, do you also get 0.02? mole. Okay, now I can say, okay, but based on the ratio between the sodium hydroxide, where do I get the ratio? I get the ratio from the balanced equation. So it's 1 to 1. That's where I get the ratio from the balanced equation. I just heard someone now ask, where does the ratio come from? So it's from the balanced equation. So in other words, if sodium hydroxide is 0.02 moles, it means the ethanoic acid is also 0.02 moles. Happy with that? Okay, now I can go to the ethanoic acid, which is CH3COOH. What homologous series is this, grade 12? Ethanoic acid. Yes, it's a carboxylic acid. I was getting nervous now. The moment I asked that question, I was thinking to myself, why did you do that? Okay, so the moles is 0.02. The mass is what I would like to calculate, and the molar mass, you can go and calculate it, but it should be 60. Everybody knows how to calculate molar mass, hopefully in grade 12. So the mass of the ethanoic acid is going to be 1.2 grams. Yes. And now I need to calculate the percentage mass of ethanoic acid that is present in the vinegar. So it's going to be 1.2 grams divided by 20 grams multiplied by 100, and that should give us 6%. So only 6% of the vinegar is ethanoic acid, okay? Which sounds very realistic to me. Now, can I take this off, grade 12? Let me give you a minute. The next question, does the salt, sodium ethanoate, that formed during the neutralization reaction undergo hydrolysis? We have already established this was a weak acid with a strong base, so yes, hydrolysis will occur, which means in this case, we will have an excess of which ions, hydroxide or hydronium? Hydroxide. So you grade 12s immediately know, one of your products will be hydroxide ions. Okay, so I'm going to show you the hydrolysis reaction. Sorry. They are not actually asking you for the hydrolysis reaction here. They just want to know if it occurred or not. But I'm going to show you the hydrolysis reaction anyway, because you might be required to write down the hydrolysis reaction in the exam. Okay, so what are we working with? Remember, hydrolysis is the reaction between the salt and water. So this is where hydrolysis will occur, between the salt and the water. Now, I have CH3COONA plus H2O. Grade 12s, you immediately know one of your products will be hydroxide ions. Okay, so you already have 1 out of 3 by just writing that down. You haven't touched the rest. You already have 1. Because you know if it's a weak acid and a strong base, hydrolysis will occur, pH will be greater than 7, which means I'll have an excess of hydroxide ions. There's your mark. Now, let's look at what is left. What's going to happen here is, it is going to break up into its ions, okay? So here we're going to have CH3COO negative, and Na plus. Happy with that? Okay. Apologies. Now let's think of water. What happens to water? Water auto-ionizes and it forms hydroxide and hydrogen ions. Okay? So if you think about it now, here we have hydroxide ions. So, in other words, there is one hydrogen still left, correct? Hydrogen is a positive charge, correct? Positive and negative attracts, correct? Aha. So in other words, I will have CH3COOH as a product. The sodium, grade 12s, is what I call a spectator. It's not going to do anything. It's just going to chill there. It's not going to do anything. Not in this case. Okay. So in other words, my hydrolysis reaction will be CH3COO negative. I omit the sodium. I just leave it out. Plus H2O. And that will form CH3COOH plus OH negative. And there is my hydrolysis reaction. Where does it start? It starts with you knowing whether hydrolysis will occur or not, and with you knowing whether it's going to be a basic or an acidic solution. Okay? And that you need to study. Happy, grade 12s? If you're happy, I'm happy. Okay. Now, let's start with the fun questions. Again, theory. So we're in today's notes today. I can't remember from which question paper this comes. I think the 2022 paper. Yeah, I think so. But this could have been the May-June paper or the November paper. I can't remember. But this is a really nice question because it really, first of all, tests your knowledge. Okay. So first of all, it tests whether or not you understand the work. You have two acids, HX and HY, of equal concentrations. Equal concentrations. They are compared. The pH of HX is 2,7. The pH of HX is 2,7. And the pH of HY is 0,7. Now, grade 12s, let's first look at that information. You know that a strong acid will ionize completely, which means it will form a high concentration of hydronium ions in solution, correct? And a weak acid, low concentration of hydronium ions. Okay. So, if pH depends on the concentration of hydronium ions, you have two monoprotic acids here. You agree? There are two monoprotic acids. They have the same concentration. Yet, the pH is not the same. Why? Because one of them is probably a strong acid and one of them a weak acid. So the lower your pH, the greater the concentration of hydronium ions in solution. The higher your pH, the lower the concentration. So if you think about it, the strong acid will ionize completely, which means it will have the highest concentration of hydronium ions, which means it will have the lowest or highest pH. The lowest pH. So if you had to choose between these two, and you were to identify which one is weak and which one is strong, you would say that HY is probably the strong acid and HX the weak acid. So when you read this question, the first thing you had to notice was two monoprotic acids And then secondly, equal concentrations. Okay. Equal concentrations. Very important. Define an acid in terms of Lowry-Bronsted theory. I'm certain you can do that by now. An acid is a proton donor. And then they ask, which acid, HX or HY, is stronger? Give a reason for the answer. So we have already identified, and we said it is HY. Now the answer you need to give here is that for the same concentration, you want me to write it down? Not necessary. Some says yes, some says no. Okay, so the first thing you need to refer to is that it is the same concentration. So for the same concentration, the pH of HY is lower. Therefore, it has a higher concentration of hydronium ions, which means it is more ionized. Okay, happy with that? There we go. Okay. Now, they say acid HX ionizes in water according to the following equation. So it forms hydronium and X negative ions. And then they tell you that the Ka value for the reaction is 1,8 times 10 to the power of negative 5 at 25 degrees Celsius. Now grade 12s. This is the same as Kc. This is just specifically the equilibrium constant for acids. So it's the same as Kc. So you see how easy it will be for us to combine acids with Kc. You see? So we can easily combine those two topics in a question. Okay? So keep that in mind. Now, the Ka value for this reaction is 1,8 times 10 to the power of negative 5. Now, grade 12s. The Ka value for Hy will be greater than this, because this clearly is a weaker acid. So the Ka will be smaller than that of Hy. Okay, so Hy will have a larger Ka value. Why? Because it is a stronger acid, which means it forms more hydronium ions in solution. Now they ask, is the concentration of the hydronium ions higher than, lower than, or equal to the concentration of HX? Sorry, I think that should be HY. That is a typing error. Of HY. Give a reason for your answer. Now, the concentration of HX will be lower than the concentration of HY, correct? Yes, because we just concluded that HY was the stronger acid. So HX will have a lower concentration of hydronium than HY. Give a reason for your answer. Because HX will ionize incompletely to form a lower concentration of hydronium ions, because HX is probably a weak acid. So it will ionize incompletely to form a lower concentration of hydronium ions, because it is probably a weak acid. Happy with that? Okay, so remember this. Make a note for yourself. Ka, if it's a weak acid, low Ka. If it is a strong acid, high Ka. And it's the same for the bases as well. Okay, so the larger the value, the stronger the base or the acid. Okay, next question. Now we get to the... So you see, that was basically theory, grade 12s. That was basically theory, only theory. So if you knew your theory, you could have gotten full marks there. Now, learners add 150 centimeters cubed of sodium hydroxide solution of unknown concentration. So we have the volume of the sodium hydroxide, but it has an unknown concentration, to 200 centimeters cubed of a 0.03 moles per decimeters cubed hydrochloric acid solution. Grade 12s immediately. Sodium hydroxide, strong base. Hydrochloric acid, strong acid. Hydrolysis, no. No hydrolysis. Indicator, bromothiamyl blue. Okay, now, they ask the following. They find that the pH of the final solution is 2. Assume that the volumes are additive. So in other words, we have 200 centimeters cubed over here, and they add 150 centimeters cubed of the sodium hydroxide. So this is our acid. They add the sodium hydroxide, and now this final solution of sodium hydroxide and hydrochloric acid has a pH of 2. The balanced equation for the reaction is HCl plus NaOH will give us sodium chloride and water. So there's our salt, there is our water. Calculate the concentration of hydronium ions in the final solution. So we have the pH, and we know pH is equal to, let me just write the formula there. So in other words, we can use the pH formula, correct? To calculate the concentration of hydronium ions. How? Because we know the concentration of the hydronium ions will be 10 times negative whatever the pH is. In this case, the pH is 2. So, let's do the question. Substitute it. Oops. So this is, let me just go over to a new page. Okay. 7.2.1. So I'm going to first write down the original formula. Therefore, the concentration of hydronium will be 10 times 10 negative, what was it, 2, hey? Okay, and what do you get? What is the concentration of hydronium ions? 0.01 moles per decimeters cubed. Happy with that? Okay. So that was an easy 3 marks. And then for 7 marks, they want us to calculate the initial concentration of the sodium hydroxide. So they want us to calculate the concentration of the sodium hydroxide. Now, we know the acid's concentration, and we also know the acid's volume. Happy with that? Okay. Now, just remember what they said. They said, remember that the volumes are additive, so they will add. Now, let's just quickly look at our formula, or our equation. The ratio is going to be a 1 to 1 to 1 to 1 ratio. We know hydrochloric acid is the acid, sodium hydroxide is our base. So, the formula that I like to use is Ca VA over CB VB is equal to NA over NB. So this is the ratio of the acid and the base, which is a ratio of 1 to 1 in this case. We would like to calculate the concentration of the acid, but we have the volume of the acid. The acid was 200 centimeters cubed. And then the base, which had a no, what are we calculating? Sorry, other way around. We know the concentration of the acid as well as its volume. We want to calculate the concentration of the base. But now, grade 12s, there's a few things that we need to consider. We now have a solution here, a final solution of 350 centimeters cubed, correct? And this final solution has a pH of 2, which means it has a concentration of, what did we calculate? 0.01 hydronium ions. Happy with that? So what we need to do, so what does it tell us? The fact that it has such a low pH tells us that which ions are in excess? Hydronium. Okay, so in other words, there is acid left. There is acid here that did not react. Some of this acid did not react. Okay, because remember, this is a neutralization reaction. This is a neutral salt. So if there's more hydronium that's now left, it means that some of the acid did not react. So what we want to calculate here now is actually the initial concentration over here. So what we're going to do, or what we want to calculate, is the acid that actually reacted. Because we know initially how much acid did we have? 0.03. So we want to calculate now, but how much of this 0.03 actually reacted? Because then we know how much was left. Happy? Okay, so the first thing I'm going to do is I'm going to still use the same type of formula. I'm just going to rewrite it as, I don't know if you've seen this formula before. Certain you have. C2V2 is equal to N1 over N1. So, first of all, the concentration of the acid that reacted, the volume, which is 200 times 10 to the power of negative 3, divided by the concentration, which is 0.01, and the volume is now 350. And it's a 1-to-1 ratio. So, that then tells me that C1 is 0.0175 moles per decimeters cubed. Let me just get a sharper pencil. There we go. So what is this C1? The C1 that I just calculated is the hydrochloric acid that is in excess. That is the hydrochloric acid that is in excess. Okay? So this is what was left. So I'm going to use this, and I'm going to subtract it from the 0.03 to calculate the amount that actually reacted. So I want to calculate the concentration of HCl that reacted. And that is going to be the concentration of the hydrochloric acid initially minus the concentration of the hydrochloric acid, which is in excess, which was left. Okay, so that's going to be 0.03 minus 0.0175, and that gives me 0.0125 moles per decimeters cubed. And now grade 12, this is the amount that was in excess. Okay, so now I can go to CAVA over CB VB is equal to NA over NB, and I'm going to substitute that. So this is what actually reacted with the hydrochloric acid. So the concentration, 0,0125. The volume initially was 200 divided by the concentration of the base, which I would like to calculate, the volume, which was 150. Sorry. Better. There we go. And this is going to be a 1-to-1. And then I see that the concentration of the sodium hydroxide was 0,0167 moles per decimeters cubed. Happy? There are, of course, other methods that you could have followed as well. So this is not the only method. There are other methods as well. So you're more than welcome to try one of those methods as well. You need to decide, grade 12s, which method is the easiest for you. And that is going to be the method that you're going to follow. Okay? Happy? Okay. Good luck with your week. And next week we will do the photoelectric effect.